Hi folks, what I'd like to talk to you about today is static electricity as it relates to vinyl records. The objective of my presentation here is to explain to you how static electricity and associated components behave, and also to tell you how to totally eliminate static from your records. Now, static electricity is the sudden transfer of energy from one object to another. And what I'm talking about here are electrically charged particles that lie on the surface of a material. Now, static electricity is generated by the flow of people and materials within an environment. So any movement that you have whatsoever, whether it be one object rubbing against another, or two objects separating, or even air flowing over a surface, all these movements can generate static electricity. Now, static electricity is highly humidity dependent. So a normal room environment, a comfortable, healthy room environment, is between 30 and 50%. And even within that range, you can still generate quite a bit of static. To give you an example, walking across a carpeted floor in under 30% humidity, we can generate 25 to 35,000 volts. And if you increase that humidity level past 80%, that number drops down to about 1500 volts. So what I'm getting at is any movement whatsoever, when we clean our record on the turntable, regardless of whatever we drag across the surface, there is going to be some amount of static generated. Now, static is also material dependent. So we say that materials or surfaces either lose or gain electrons. So if we look at this, this is called the triboelectric series. This is a list of materials, and you can find dozens of these online. The only differences among them are that some list more materials than others, but basically they're the same. So we consider cotton to be a neutral material. So cotton doesn't charge well and it doesn't hold a charge well. As we go down this list, these are materials that gain electrons and become increasingly negative. And if we look up this list, these are materials that that lose electrons increasingly and become more positive. So if we look down toward the bottom of the list, PVC, or polyvinyl chloride, from which our records are made, is relatively low on the list. Therefore, it likes to take in electrons and charge negatively. And on the other end of the spectrum, we have air, human hands, skin, hair. These lose electrons and get highly positive. So the farther away the two materials we're comparing are from this list, the greater the potential difference can be as far as static charges are concerned. Now, let me start by saying, let's talk about anti-static, the term anti-static. Anti-static does not mean zero static or that an object cannot be charged. Anti-static, there's only two ways for a material to become anti-static. One way is to coat it with either an oil, a wax, or even refined animal fats are used. So it would be a coating on the material that is hygroscopic. That means it absorbs moisture, it tends to absorb moisture. And then they won't charge as much. But there will still be a charge on it in low enough humidity levels. The only other way is to add modifiers to the base material, the base plastic in this case, and which will help reduce the charge but again, it will not eliminate the charge. Now, on this triboelectric series list, there are also conductors, so there's metals. And just because something is a conductor doesn't mean that it cannot hold a charge on its surface. And what I'm getting at with this is that you cannot ground an insulator. So PVC is an insulator. It does not conduct electricity. So now I'm not trying to disparage any products. I'm just trying to explain how they work or how they behave. So if we look at, for instance, an anti-static brush. Now what I have here is an anti-static brush that's grounded to earth ground. And also what I have here is an electrostatic field meter. So this measures the charges on the surface, and it also indicates whether they're positive or negative charges. So to start with, you cannot ground an insulator. That's just the physics behind it. The only way that fact changes is if the laws of physics change. So if I turn on my record and turn on the meter, and I swipe this brush across the surface, I'm getting several hundred volts, almost 1,000 volts. My humidity level in this room is 41% at the moment. So it just goes, I'm just trying to illustrate to you that even a grounded conductive material will not eliminate the charge from the record. It will change it slightly, but nevertheless it's still going to charge. Now the problem with static electricity, other than the obvious reasons that our cartridges can pick up the pops and clicks from static on the record, the other problem is that dust that's floating in the air is bipolar. It could be either positive or negative particles of dust that are attracted by a charged PVC record. So whether you use a conductive brush or a natural bristle brush or whatever, you're still going to generate a charge. It just hit 1,000 volts. So again, whatever you drag across the record is going to generate a charge. Now, the only way of eliminating the charges on a record is with air ionization. So there are air ionizers that are specifically made for this use for turntables, and I believe that the way they work is that they just flood the surface with positive and negative ions and neutralize the surface. Now what I use here is I have what's called a benchtop ionizer. So this is a unit that has a fan in it, and it has sensors that sense the flow of air through it. And then there's 4 electrodes here that emit ions opposite the polarity of what it measures or what it senses of the air going through it. So I have it connected to a foot switch here. So I actuate the foot switch, turn on the fan, and within about 0.8 of a second, depending on the distance away from the turntable, in about 0.8 of a second, it drops the charges down to 0. And then I take my foot off the foot pedal and then play the record. So I'm playing a record that has 0 static on it, truly 0 static. Now, whenever I wipe the surface off again, I'm going to recharge that record. To give you another example, is I have an anti-static record sleeve here. So when I take a record out and put it underneath I'm measuring 2300 volts. So again, any movement, any sliding, any separation is going to generate static. So again, I believe that air ionization is really the only way to do it. There's no, and also our record should be as clean, in my opinion, as possible when we place it on the turntable. So that means no residue, no fingerprints, and of course no particulates. So I hope this presentation has helped you to understand this a little bit better and give you an option to treat the records to eliminate the static. Thank you for listening, and feel free to contact me if you have any questions or need any other information. Thank you.